Good morning to all. I am Dr. Ashok Kumar, Associate Professor in the Department of Mechanical Engineering. I am going to handle conic sections in engineering graphics. What is a cone? A cone has base circle at its bottom and a point called vertex or apex at its top. Suppose consider the cone is cut by a plane. Then based on the position of the cutting plane, we can get various types of conic sections. If the cutting plane is parallel to ground, then we can get circle at its top. If the plane is perpendicular to VP and inclined to horizontal plane, then we can get elliptical shape at its top. If the cutting plane is parallel to one of its generator, then we can get parabola. The cutting plane is perpendicular to the ground plane, then we can get hyperbola. So based on the position of the cutting plane, we can get various types of conic sections like ellipse, circle, hyperbola, parabola. We have many methods to draw the conic sections, but in our syllabus we have eccentricity method. What is eccentricity? Eccentricity is a distance between the focal point and the vertex divided by distance between the vertex and the directrix. If this ratio is less than 1, then we can get a conic section called ellipse. If both distances are same, then we can get parabola curve. If eccentricity is greater than 1, then we can get hyperbola. So this point is called, point F is called focus point, point D is called vertex point, AB line is directrix. So for ellipse, distance between F and D is minimal when compared to distance between C and D. Hence its ratio is less than 1. For a parabola, distance between focal and vertex point is equal to distance between directrix and vertex point, that is FD equal to CD. So we can get E equal to 1. If the curve is hyperbola, means distance between focus point and directrix when compared to distance between directrix and vertex is high, that is eccentricity is greater than 1, we can get hyperbola. This is the sample elliptical curve. So its dimension is given in the problem. Distance between directrix and focus is 30 mm, but eccentricity is 2 by 3. So eccentricity is less than 1. So we can get elliptical curve. Here we see FD distance is lesser than distance between C and D. Hence its eccentricity ratio is less than 1. We can get elliptical curve. See this curve. Here distance between focus and directrix is 30 mm. Its eccentricity is 1. That is distance between focal and directrix is equal to distance between directrix and vertex point. That is CD equal to FD. Hence its eccentricity ratio is 1. We can get parabola curve. For hyperbola, distance between the focus and vertex point distance is higher than the distance between the directrix and vertex point. Hence its eccentricity ratio is greater than 1. See this problem. This eccentricity is 4 by 3. Its value is more than 1. Hence we can get hyperbola as a conical curve. So based on the eccentricity value, we can get conic sections like ellipse, hyperbola and parabola.